Hello, my name is Jasok Cho, and I will present the findings after analyzing this case study. First, let me introduce the attack tree diagram. As you can see in the table, there are three potential type of trees. The first one is spear phishing email, and the second one is DDoS attack, and the last one is data theft. Potential cyber threats come in the form of these causes and effects. Next, I conducted a list of risk assessments using the CIA tried. Starting with the spear phishing attack, this threat compromised the confidentiality of the company's network by gaining access to critical information. Additionally, if this information is manipulated, it could lead to a loss of integrity. However, it was found to have no direct impact on availability. Moving on to the DDoS attack, uh, it does not direct affect confidentiality or data integrity. However, it seriously impacted availability as it prevented company employees from accessing services, resulting in potential financial losses and reputation damage. Lastly, data theft. Data theft directly affected the confidentiality as it exposed sensitive information. Furthermore, the potential for data manipulation or alteration also poses a risk to data integrity. However, data theft did not have a direct impact on availability. Uh, Now, let's discuss some solutions for DDoS attack and data theft. First, intrusion detection system (IDS) can be helpful in mitigating DDoS attacks. Uh, IDS monitors network traffic and system activities to detect malicious behavior, which can aid in recovering the disrupted availability in this case study. Additionally, IDS provides detailed information about the DDoS attack, helping security managers understand the incident. Second, software-defined networking. Uh, SDN is another solution. With SDN, network administrator can directly control and manage the network in a centralized manner. This allowed them this allowed them to detect abnormal traffic patterns and track the traffic IP source for remover notification to the administrator. Lastly, contents delivery network. CDN technology can also be beneficial in mitigating DDoS attack by redirecting the flow of network traffic to backup servers and caching website contents. So CDN minimize the of burden on service servers, effectively countering DDoS attacks. Now let's move on to the data theft solutions. The first solution is multi-factor authentication. MFA uh, is a security mechanism that confirms a uh, user's identity through various steps and methods before granting access to data. It can be categorized into knowledge factor, such as PIN number, OTP, and possession factors, KEPO, and inherence factors, such as fingerprint scan and voice authentication. By implementing MFA, even if hackers obtain the company's system password, they would be prevented from accessing it due to the additional authentication factors required. The second solution is email security gateway. In this case study, the lack of email security gateway technology allowed the criminals to access companies' network data without authorization. Implementing this feature can help recover the compromised confidentiality. It includes keyword matching, URL filtering, detecting phishing emails, preventing them from reaching detecting phishing emails. The last solution is data loss prevention technology. DLP maintains comprehensive inventory of network data and tracks data mobility on portable media. This this real-time monitoring capability helps prevent data loss. Based on the solutions provided for DDoS attacks and data theft, I will now present what I consider to be the best solution. From a DDoS attack mitigation perspective, I believe SDN technology is the best solution. Not only does it counter DDoS attacks, but it also offers various other benefits. For instance, uh, SDN controllers enhance network for performance and simplify uh, network operations and management. Additionally, SDN technology does not require human involvement during the execution and maintains DDoS mitigation. So it's saving human resources. Regarding data depth, MFA technology seems to be the most suitable solution. This is because cyber criminals are likely to fail authentications attempts with factors such as fingerprint scans or voice authentication. Moreover, MFA is relatively cost effective compared to other technologies, making it feasible for scale businesses to prevent data theft efficiently. Thank you for your listening. This is what I learned from the case study. Now I'm gonna demo how to encrypt with the symmetric key. Let me open the terminal. Uh, First, I will show you symmetric key encryption with AES. First, I'm gonna make a file called plain text. And put some information. And check it. Yeah, there is an info. Now we are going to encrypt it with OpenSSL in code. Mm, Open SSL and encrypt AES 256 and input plain text file and output cpr.txt. Now let me type the password QWER1234 again. Yeah. It recommends us to take a better version of this bag. So I'm gonna show you how we can do this, how we can apply the updated version. Again, open SSL and encrypt AES to 56. And now we are adding iteration. Iteration like 3. Input blank text file and output C secret text. Now I will put the password. Yeah. Um, let me check the encrypted file. Yeah, as you can see, it's encrypted well. Now, next, I will show you how to apply DES for the symmetric encryption. So let me clear terminal and first make a file called dot.txt and put some information. And you can check it. There is information. And now hmm, apply a zipper. Open SSL. And now we are going to encrypt this file with DES. Uh, encrypt ES ECE input plain text file and output double dot com. And let me type the password. Yeah, and now you can check the encrypted file with DES. Yeah. Yeah, it's encrypted well. Let me clear. And before the move on to the public key cryptography, I will remove the file I just made. Yeah. Now I will show you how to encrypt and decrypt with LSA key. I'm gonna make a file called plain text. Plain text. Just some like information and check it. Yeah, there is an info. Now, uh, we're gonna generate the RSA key pair. Open SSL, generate RSA, output key, and file 1024. I'm gonna choose the size of key is 1024. and the check if the primary key created well or not. Yeah, this is what it looks like, what a primary key looks like. Then to see the detailed information about how the key pair was created, just uh, type the nut command RSA and key pen text. No. RSA in key pen out. No, 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 no. Sorry for the in key pen and text. Yeah. This is the more detailed information. And then extract the public key from the primary key. Open SSL and RSA and input key pen file and output public key pen file and file. Yeah, it's writing RSA key. Now you can check the public key. Public key and yeah, you can see the public key, what it looks like. Now, we are gonna go ahead and encrypt the plain file. We will open SSL, and we will use RSA utility pkey utility input plain text file and output for text and public key in key and pub key and encrypt. Yeah, you can check the shipper file. Yeah, it's encrypted well. Now we want to decrypt the file. So again, pkey utility, pkey pkey util input text output is super text and in key can decrypt. Yeah, and you can check this decrypted file. Yeah, there is an info that I put at the first time. Now I will show you the asymmetric asymmetric as asymmetric cryptography. The RSA digital signature. Before do this, I'm gonna delete the file again and clear terminal. Yeah, I'm gonna make the file called again. and put some information. It reads and check it. Yeah, it has secret information. Now I'm gonna make a private key. Open SSL, generate RSA, output private private key. And now this time I will pick the size of key is 48. Now you can check the uh, primary key. This is what it looks like. Now I'm gonna make the public key from the primary key. Open SSL, RSA, input, primary key pen, hub, out, public key, pen file. Yeah, it's writing RSA key. And I'm gonna hash file using SHA-256 and sign the file using the primary key. Mm. And I'm gonna use the digest function. Open SSL, SHA, and sign primary pen, and output sign SHA plain text. Yeah, I want to check if it's verified. Open SSL, digest, SHA 256, and verify, and code verify, public key pen, and encode signature, sign, SHA, plain text. Yeah, it's verified. Okay. We successfully put signature on it. Yeah. Thank you for the listening my demo.